Moving on to question 4. Here we're given a parabola with this equation and the line PQ which touches the parabola at the point Q. The first part, show that h is equal to 3, h being the x-coordinate of Q, and second part, calculate the area of the shaded region. So anyway, let's put the diagram on top for easy reference. So first, we look at the equation of the parabola, which equals to y equals 4x minus x squared. We differentiate that, dy dx, which we are familiar with, and that becomes 4 minus 2x, which gives a slope at any point on the curve. And at Q, we know that x is equal to h, so dy dx will be equals to 4 minus 2h at point Q. At the same time, we know that if there's a line joining points PQ, P being 2, 5, and Q being h and 4h minus h squared, the slope of this line, which is also the slope at Q, is given by five minus 4h minus h squared over 2 minus h. And since both these expressions are slopes at Q, we can equate them. So we can say that left side equals to the right side, and after some algebraic manipulation, we'll have the expression and we'll not end up with a nice quadratic in h squared, which h squared minus 4h plus 3 equals 0, and that can be factorized into h minus 1, h minus 3 equals 0. And in the usual case, we will say that h is either 1 or 3. But since h is more than 2, so we know that 1 is not possible, so the answer is h equals 3. And you can state because it's more than 2, which proves the first part as required. For the second part, so basically to calculate the area under the curve, we first have to work out the slope of the equation. I mean the slope of the line PQ and the equation of PQ. So let's look at PQ. The slope is basically 4 minus 2h, and we know that h is equal to 3, so 4 minus 2 times 3 is negative 2. So the slope is equal to minus 2, and with the equation, basically y minus 5 is equal to slope into x minus 2. And after some rearrangement, we have y equals to minus 2x plus 9. And that's the equation for PQ. The area under the curve of the shaded region is basically the integral of 2 to h, which is 3, of the line minus the equation of the curve. So you take minus 2x plus 9 and subtract 4x minus x squared and integrate that whole thing with respect to x. And if we rearrange this, we will end up with x squared minus 6x plus 9 dx. Now this happens to be just x minus 3 squared, which is very convenient because we can substitute x minus 3. We can basically put u is equals to x minus 3 and du is equals to dx. So when you when x is 2, u is minus 1, and when x is 3, u is 0. So this is basically the integral of u squared du, which is basically u cubed over 3 from minus 1 to 0, and that's just 1/3. So the area shaded of the shaded region is 1/3.